Hi everyone, I'm going to go ahead and get started and work on the review, finish up the entire thing. If you were just looking for the word problems number 9 through 12, that is on the other video. Okay, this one here, this is going to be the entire review. So if you're looking at this one, just skip over to the numbers that you need. Okay. All right, so if there's some reason that you get to class any day and you don't see what's to do on the board, please go over to Canvas modules and I will have it listed there as well. All right, so let's talk about number 1 here. For those of you guys that were here yesterday in class, we got through number 1 through 8. On this one, we are finding the percent of increase or decrease. So I'm going to be looking at the B value to first determine whether it is a growth or a decay. So number 1, the B value is 0.875. Okay. With that, it is less than 1, which means it is between 0 and 1. So this one is a decay. When we have a decay, we take 1 minus the B value, and that'll let us find the rate. So 1 minus 0.875. Okay, and you should have a calculator in front of you to make sure that you're actually practicing this so that you get the same correct answers on the test. So the rate is 0.125. Convert that to a percent, and we have 12.5%. All right, over to number 2. On this one, if you are comfortable with e to the 0.4 times x, you can do that. If not, replace e with its estimated equivalent value, 2.7182. We are taking that and we are going to simplify the base with the exponent. So 2.7182 to the power of 0.4. And that'll give us 1.4918. 4 places after the decimal, please, to the power of x. All right, so just looking at the base value, that base is a growth. So when we have a growth, we're going to do 1 minus that value. Now, if you did that value minus 1, actually, I'm doing it backwards. If you were to do 1 minus this value, then it's going to give you a negative value. Remember that the rate will always come out positive. Okay, so I'm going to do 1.4918 minus 1. This will give me my rate of 0.4918. Now, turning the rate into a percentage is moving the decimal 2 places to the right, multiplying it by 100. So we will have 49.18%. All right, so now let's go on to problem number 3. On problem number 3, we are describing the transformation and we are graphing this. So we need to know first off whether it's exponential or it's a log so that we can find out those easy pieces. This one here is an exponential because it doesn't have the word log. The pieces that I quickly know is I know the horizontal asymptote is y equals k, so that's y equals negative 9. I know the domain in exponential, that is negative 8, or negative infinity to positive infinity. I know the transformations. This one here is going to go horizontal shift to the right 4, and a vertical shift down 9. Okay, so I'm going to go ahead and draw in the horizontal asymptote since I know it. Remember that exponential has horizontal and logs have vertical. Make sure that you label the asymptote. So that's y equals negative 9. All right, to find this middle number right here, we take the exponent and we set it equal to 0. So x minus 4 equals 0. Gives me positive 4, 5, 6, 3, and 2. Okay, then on this one, we're just going to take this, the highlighter, this x value right here, and I am going to replace it with each of these x values. So the first time I do that, I have 2 minus 4, so that's going to be negative 2. So 0.5 to the power of negative 2 and then minus 9. Now remember, we don't clear our calculator until the very end, okay? Because if you clear your calculator sooner than that, it's going to give you an estimated value. It's not going to be as accurate as we would like it to be. So this one here will be negative 5. All right, the next time we are not going to have negative 2 up there, because we're going to plug 3 in for x. And 3 minus 4 gives us negative 1. So now I have 0.5 to the power of negative 1, and then minus 9, and I get negative 7. All right, for the next one, I'm going to put 4 up there. When I put 4, 4 minus 4 makes 0. 0, anything to the power of 0 is 1. 1 minus 9 makes negative 8. Okay? Right, when we have 5 up there, it is 0.5 to the power of 1, which is 0.5 minus 9 gives me negative 8.5. The last one, we put up there negative 6, positive 6. 6 minus 4 gives me 2. 0.5 to the power of 2 minus 9 gives me negative 8.75. We'll go ahead and graph those points. So I have 2, negative 5, 3, negative 7, 4, negative 8, 5, negative 8.5, and 6, negative 8.75. This one here is going to get very close to that horizontal asymptote, but not cross it and not touch it. On the other end, it can go off the graph, so make sure you draw it all the way off the graph. Okay, looking for the range. How low does it go? It goes as low as negative 9. How high does it go? It goes as high as positive infinity. All right, end behavior. As x is going to the left, it's going towards negative infinity, it is also going up to positive infinity. On the right end, as it is going to positive infinity on the x-axis, it is going down, but it is only going down to negative 9. All right, so let's go on from that one, and let's go do one that is log. So with a log, I automatically know that I'm going to take the argument, and I'm going to set it equal to 3 numbers. Those 3 numbers are going to be 0, 1, and the base. In this case, the base is 4. Solve for x by subtracting 2 from each side. So I have x equals negative 2. I have x equals negative 1. And I have x equals positive 2. When we set it equal to 0, that is our vertical asymptote. So that is x equals negative 2. Those are 2 values. We'll go along our tables. So negative 1, positive 2. We know the range on this one will be negative infinity to positive infinity. I can quickly identify the transformations. It is going to have a horizontal shift left 2 and a vertical shift up 1. I'm going to go ahead and draw the vertical asymptote so that I've got that ready to go. Remember to label it. Okay, plugging in negative 1 into our equation, I have log 4 of negative 1 plus 2, and then plus 1 for the k value. So that's log 4 of 1 plus 1. Log 4 of 1, anything to the power of 1 is always going to be 0. So I have 0 plus 1. Alright, on this next one, we're going to plug in 2 for x. So log 4, 2 plus 2, and the k value is plus 1. So I've got log 4 of 4 plus 1. This here gets replaced with 1. So 1 plus 1 gives me 2. So I have negative 1, positive 1, and positive 2, positive 2. Know that this is a log, what a log graph should look like. Alright, so the domain on this one, it goes as far to the left as -2, and it goes to the right forever and ever. That's positive infinity. The transformations, as x goes to the left, it goes up to goes to the left to -2, and there it's also going down to negative infinity. On the right side, it is going up to positive infinity, and or it's going right to positive infinity, and it's also going up to positive infinity. Right? Okay, I'm going to stop this video here so that we've got part 1 done, and I'm going to go back and I'm going to turn the page over and go to part 2.